Okay, so there are two levels of uncertainty here. We went out, all we did was grabbed a bag of M&Ms, counted, took us, what, a few minutes, and from that, we're able to make a prediction about every M&M in the entire universe. We can make this really strong prediction. But there are two levels of uncertainty here. First off, I got to leave this wiggle room. The sample said it was 25%, but I got to kind of fudge a little bit there. I got to hedge my bets, plus or minus 6%. And then there's the second level of uncertainty. I'm only 95% sure of either of these numbers. There's a 5% chance that we're completely wrong. But still, we only did one sample, and that's still pretty darn confident. There's only a 5% chance that we're wrong, and we've narrowed down what fraction of all M&Ms are green. So confidence intervals are very powerful, but there is this little bit of uncertainty in your answer. Okay, let me show you how to do this on your calculator. So here in the calculator, from now on for the rest of the semester, we're going to go stat over to tests. Everything we do from now on will be here in this button. If you don't have one of these calculators, you won't be able to do another problem the rest of the semester. I can't emphasize this enough. I've been saying this since day one. You must have a graphing calculator that has these statistical tests in here. Okay, now we got a whole bunch of choices here. We're just going to scroll through until we find the one that looks like what we're doing. So for test 3, you should write this down. The only buttons you're going to use for test 3 are 5, 6, A, and B. I'm going to write that on my whiteboard here. 5, 6, A, and B. That's test 3. Because those say prop. We're doing proportion problems. See right there, prop, 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 and prop. Now we got to figure out which one of those 4 fits the problem we just did. Are we doing a hypothesis test or a confidence interval? You guys don't even know what hypothesis tests are yet. So we're not doing a test. We're not doing 5 or 6. It's got to be A or B. See how it says interval on there. Okay, did we have 1 sample or 2 samples? How many N's did I have? There's just 1 N. See, if I go into button B here, look, it's asking me for 2 different X's, 2 different N's. I don't have all that. So that's clearly not the right button. Out of all these buttons, the only one that has everything I literally wrote down is button A. It's asking for X and N. Those are right there. So I type those in, 50 and 100. My confidence level, the question asked me for it, was 95%. I hit calculate, and I'm done. That's my interval. Oh, wait, I typed something wrong. Let me redo that. That interval was not right. N was 200 right there, 200. Hit calculate. Test. 1 prop interval. Oh, 200. We hit calculate, and we're done. 19%, 31%. That's it. That's the entire problem. What if we wanted to be more confident? Let's work on the same problem. So for 95%, we had we are 95% confident that between 19% and 31% of all M&Ms are green. Let's do 99%. Let's raise our confidence. Let's be more sure about our answer. So the only thing I have to change here is make this confidence level 99%. And look what happened. Now we're at 17 to 33% almost. So before I was at 19 and 31, now I'm at 17 to 32. So we would write the sentence, we are 99% confident that between, don't forget the word between, I'm going to change the screen in just a second, 17.1% and 32.9% of all M&Ms are green. So that would be our sentence. So it's always we are blank percent confident that between lower and upper of all, we're making a prediction about the entire population here, M&Ms are green. Notice my interval got bigger. My margin of error went up. The more confident we are, the more wiggle room we have to leave. It's a balancing act. I'm going to make a statement now, and if anybody can prove me wrong, I will give you an A in the class. You don't have to do any more work. I will put in an A right now if you can prove me wrong. That's how sure of this statement I'm about to make. I'll even write it down. I am 100% confident that between, you guys know that symbol for between, BW? You do now. That between 0% and 100% of M&Ms are green. I am 100% sure that the fraction of all M&Ms that are green lives someplace between 0 and 100%. Of course, you're not going to be able to prove me wrong on that. Nobody's getting a free A. Of course that's true. If we go up to 100% confidence, our margin of error becomes so big, we're not saying anything. So there's a trade-off. The more confident you are, the bigger your margin of error gets and the more wiggle room you have to leave. So as your confidence level increases, goes up, your margin of error also goes up. It's a balancing act. What if we took a bigger sample? So if we look back at the math that's happening in the background here, if I have a bigger sample, if n gets bigger, then dividing by something bigger makes a fraction smaller. My standard error would get smaller, which would make the margin of error smaller. So if I want to be more confident in my answer, I need to take a bigger sample. If I want the margin of error to go down, we make n bigger. So as n goes up, the wiggle room, the margin of error goes down.